Here is a very different way of solving this kind of trigonometric identity where you have tan or tan square x. Now normally if you have an identity with tan, the best thing is to rewrite tan as sine over cos, correct? So the standard way of solving this is you should write always tan x equals to sine x over cos x. So that is the normal way of doing, right? Now this strategy is very effective. It works for simple questions, right? But at times what happens is that it becomes very lengthy if you follow this process in questions like this. So what I do is I adopt a strategy and I don't really substitute tan x as ratio of sine or cosine. What I do is something like this. I'll show you what I do. So what I do here is tan x equals to sine x over cos x. But if I multiply by cos x, what happens? If I multiply by cos x, what happens? Both sides. Then you see cos x cancels and we are left with sine x. So that is the strategy. So what I can do is I can multiply and divide by cos x. If I have tan square x, I'll multiply and divide by cos square x. Do you get the idea? So then I simplify by a large extent. So look at it once again. If I have tan square x, let me do it here now. So if we have tan square x, that means it is sine square x over cos square x, correct? Now if I multiply and divide by cos square x, then what happens? Then this gets cancelled. Do you see that kind of thing? So that is the whole idea. Basically, if I multiply tan square x by cos square x, I'm left with sine square x. So that is the strategy I'm going to apply here, right? And let's see how we can solve using this strategy. So we start with left side, which is tan square x. So we have tan square x plus 1 over 1 minus tan square x. We need to prove it is 1 over cos square x minus sine square x. So as I'm saying, my strategy here is to multiply and divide by cos square x. So that is the strategy. What will happen? Now in this particular case, it is really very effective strategy. When I multiply tan square x with cos square x, as you have seen, you get sine square x. So what I get here is sine square x. When I multiply cos square x with tan square x. And with 1, I get plus cos square x. Do you see that? In the case of denominator, I'm multiplying with this cos square x, both these terms. So I get cos square x minus tan square x times cos square x is sine square x. Do you get the idea? That is what I'm trying to use, correct? Now in just one step, I get my answer. Sine square x plus cos square x is 1 and over cos square x minus sine square x. Do you see the result? So it is that effective, that effective. Let's see it once again. We'll apply the same strategy here. So we'll start this time with the right side, okay? So right side for us is, now this one is equals to the right side and therefore we proved it, right? Right side in this case is tan x over 1 plus tan x, correct? Now what should I do? Now in this case I should multiply by cos x. Do you see that? So I'll do with cos x, correct? So if I do that, then tan x times cos x is what? Sin x. Do you see that? So we get sin x in the numerator, and in the denominator I'll multiply cos x with 1 plus tan x. So I'll get cos x plus sin x. That is my left side. Do you see that? So this strategy is so nice. If you get into tan x equals to sin x over cos x, you get multi-layer fractions, and at times it becomes very difficult to solve those questions, right? So that is how you can solve these questions. So apply multiplication rather than division. That is what my preference is. So in such cases, wherever you find tan, instead of writing tan as sine over cos, prefer to multiply both numerator and denominator by cos so that you can eliminate the common denominator altogether and get to the result faster. I hope you appreciate it. Thank you.